Yann, welcome.
Pleasure to be here.
We're going to chat about some topics tonight that I think are on everyone's mind, and I know that you're incredibly well thought out on. And so I hope it'll be an informative discussion. Let's keep it informal, back and forth. I guess before we get too much further, let's make sure that everyone, well, I'm sure everyone knows you, but just to be clear, so Yann LeCun is VP and Chief AI Scientist at Meta. And that is part of the fundamental AI research organization. And I think what's very interesting is the way Meta has started to split things in recent year and a half, I think it has been, right?
2 years.
2 years, which is LLM-based research and application, and many applications thereof are part of the product division now. And FAIR is focused on what's next, right? New architectures, new approaches to bring full intelligence, or much fuller intelligence, to AI systems. So I hope we can explore that tonight, and especially interweave the important topic of open source and open innovation.
Absolutely, and you got it right. Yeah, it was about 2 years ago when Mark Zuckerberg and, Buzz, the CTO, and also Chris Cox decided to create a new pillar, a new product pillar. So Meta now has 5 product pillars: Instagram, Messenger, Facebook, and WhatsApp, plus Gen AI. And Gen AI really is not about generative AI necessarily, but it's about like old products that are AI first, and their source was a bunch of people from FAIR that were basically kind of transposed to Gen AI and constituted the nucleus of the engineering team for Gen AI. Since then, Gen AI has grown to, thousands of people. And they are the ones who are producing Llama and, all the products on top of Llama, Meta AI, which is the AI assistant that Meta is offering through WhatsApp, Messenger, and Facebook. And the ones that run all those smart glasses like this one, except in Europe. At least it's crippled in Europe because of regulatory uncertainties. But if you want to go to details about this, you should talk to Rob. And so the effect of this has been to free FAIR to basically think longer term about the next generation AI system, and that's really what we were working on. That's our mission now. We call it Advanced Machine Intelligence, AMI, but we actually pronounce it AMI, like in French, because it means friend in French. I think that's appropriate.
So let's start with where things are today. Clearly, LLMs, autoregressive approaches, have been demonstrated to be very capable in many circumstances. Meta wouldn't have a product division. IBM wouldn't have a whole basis of our products based on LLMs, essentially. Many other companies the same. So let's just talk for a few minutes about what are LLMs good at and what aren't they good at.
Yeah, certainly LLMs are very useful. And I think a big surprise that it sort of fell on a lot of us in late 2022 was the enthusiasm of the public for chatbots of this type. Because, many of us, Clément Farbe is right here, he's a VP at DeepMind, he's a former student of mine. And people at Meta and Google had been like putting out research prototypes of LLMs and dialogue systems and stuff like that. And there was basically no interest from the public. Some interest. In our case, we actually put one out in October 2022 called Galactica, and it was trained on the entire scientific literature, and it was designed to help scientists write papers. And it was really cool. We were starting to kind of integrate this in all the tools that scientists use to write papers, that are online for collaborative writing. And that thing was doused with vitriol. There was an entire community of people on Twitter, but it's Twitter, that basically said, oh, this is going to destroy society because, now, any random stupid person can write a paper that sounds authoritative. And so, I'm going to ask you to write a paper on the benefits of eating crushed glass. And of course, the thing, writes a paper on the benefits of eating crushed glass. See, people are going to die, because of that. I mean, how stupid can you be? So the bad publicity was so bad that the people in the team working on this didn't come from, the communication departments or PR or marketing or anything. The people in that team sort of couldn't sleep at night and they took down the demo. They left the code open source and the paper and everything, but they just couldn't leave the demo. And so we said, the world is not ready for those things. And then 3 weeks later, ChatGPT comes out, and it's the second coming of the Messiah, right? So it's like, what? What just happened? So that was a big surprise for us, but it was a big surprise for people at Google, I'm sure. I mean, you were still at NVIDIA then, no? Yeah, right. So, different time. Yeah, right. Well, he was at NVIDIA, so he quit the weapon supplier in the AI war and then joined one of the factions. That was kind of a big surprise. So LLMs are really great. They're useful for a lot of stuff, but they have to be trained for everything that they need to do. They cannot do something new without being trained for it. And that's a huge limitation in the sense that you have to have like what's called a post-training phase where you have people kind of giving feedback to the system, training it to answer particular questions, blah, blah, blah. And you cannot actually cover the totality of everything that people want to ask an LLM. So you end up with systems that have partial training that will hallucinate, that will, that can be jailbroken and all kinds of stuff, right? And the limitation is due to the fact that, at least in their current form, those systems basically do not really reason. They produce one token after the other. And they can't really think for a long time about something before answering a question. So people have been using tricks that have appeared in the last year or so, chain of thought and things of that type, that basically trick the system into producing more outputs so that it sort of makes it, spend more computation on complex answers. But that's kind of a trick. So in the future, what we need to do, and it's also very expensive at runtime. It's another phase. The other way to trick an LLM into reasoning is that you have it generate lots and lots and lots of sequences of words or tokens, and then you have another network that picks the best ones, right? And that's just horribly expensive at runtime, which is why you have to pay $200 a month for to OpenAI to just use that in part. So one question we've been sort of asking ourselves, is there a different architecture that would really have reasoning at its core? It wouldn't be like a bolted wart on top of an LLM. It would be kind of, the basic design of it.
Yeah, I wanted to just ask you about a couple things here. Very, very, really interesting stuff. So first, I'd like to come back to Galactica and AI for Science a little later. I remember that vividly because I was also working in AI for Science at the time. Many challenges and interesting things. But just on the subject of LLMs, as you said, yes, we have been able to trick them to do certain things. We've been able to, make it seem like they can reason in some circumstances, seem like they can plan. Certainly, huge amounts of attention on interaction with other systems and retrieval. Now,
you mean RAG?
RAG, yes.
That's a meta-invention.
Yes, that's right.
It came from FAIR.
That's right. So these are useful things, but fundamentally, what's happening? Are we actually teaching the model to reason? Are we teaching the model to interact in an intelligent way, or is it?
No, I don't think we are. I think so. There is this herd effect that, it's the hammer and nail effect, right? When you have a hammer in your hand, everything looks like a nail. So I think to some extent there is a bit of that happening with LLMs. That we have LLMs and we know how to train them efficiently, and we can tokenize any kind of data that we think we can tokenize any type of data. And so let's just apply LLM to everything in the world. And it may work to some level, but there are dire limitations. So for example, you want to apply LLMs to do video prediction, because so here is something really important I want to say, right? There's 4 essential characteristics of intelligent behavior that every animal or relatively smart animal can do, and certainly humans, understanding the physical world, having persistent memory, being able to reason, and being able to plan, and planning complex actions, particularly planning hierarchically. And every animal can do this. If you look at a cat, they can definitely all four of those things. LLM by themselves are incapable of doing any of those things. And what a lot of people are doing is, without changing the major paradigm, which is because it's difficult and because you need a long horizon for that, what can you do to sort of tweak the system so that it goes towards that direction? So for understanding the physical world, well, you train a separate vision system, okay? And then you bolt it on the LLM. And for memory, you use RAG, or you bolt some associative memory on top of it, or something like that, or you just make your model bigger. And then for reasoning and planning, it's the techniques I was just describing. But those are hacks that do not put into question the basic paradigm. I think what's necessary ultimately is really kind of questioning the basic paradigm. Now, of course, that takes a long time. You're not going to do this if you have a team of 200 people under the gun from either Sundar or Mark, breathing down your neck saying, so when is the next version coming out, right? You're not going to change the basic paradigm. You're just going to kind of go incrementally. So what you need for this is a separate group with no one breathing down their necks, having a long horizon and basically having the ability to sort of reinvent the paradigm. So that's what FAIR is. That's what AMI is, really.
So let's go there now. Yann, you have said many things about the future architectures of AI. I think you've said, maybe I'll paraphrase, not put words in your mouth, but something to the effect that if you want to solve interesting problems in AI, don't work on LLMs. Yeah,
absolutely. I mean, I certainly tell that to graduate students, because they would be in competition with enormous teams of engineers with tens of thousands of GPUs for most of us, TPUs for a few of us. So he's in charge of infrastructure at DeepMind and everything, so he knows everything.
He's come up a few times. Would you like to join us?
I can tease you a little bit. Don't work on LLMs. It's pointless. Like, try to invent the next thing. Propose ideas that would allow AI systems to do what they can't do today.
For sure, for sure. So let's go a little deeper into that. Yann, we met about 7 years ago at NYU discussing quantum computing. Now, by background, I'm a physicist, and so one of the things that's bothered me about AI, at least the current generation of LLMs, right, is essentially they're very good at matching patterns. Their autoregressive prediction is basically looking at patterns, predicting. It works particularly well when you have discrete quantities, tokenized language, and so on. But there's no physical basis. And this is something that you've worked on and talked and pursued quite a bit. So I'd like to kind of switch gears and talk more about that, right? How do you inject more intelligence, more understanding of how the world really works at a foundational principles level into future AI systems?
So as humans, we are, many of us are kind of biased into thinking that thought is based on language. But in fact, that's just not true. Like, most of thought has nothing to do with language. Most of the things that we learn, certainly everything we learn in infancy, has nothing to do with language. We have mental models of the world that are completely disconnected with language. There's a lot of people who can't talk, can't speak, can't manipulate language, and they can think. Certainly animals can think, and including the ones that don't have any particularly sophisticated language. Like, if I give you an example, like, imagine a cube floating in front of you. Now imagine that cube rotating by 90 degrees around a vertical axis. And what you do is kind of, you imagine this mental picture of a cube rotating, and you realize if you rotate by 90 degrees, it's going to look the same as when it started. Because you have this imagery, right? You know that if you take one of the glasses that's on the table, and you push the glass on the foot, the glass is going to slide on the table. But if you push it from the top, it's probably going to flip. Right? You have those physical intuition, and we all learn this in the first few months of life. And it's mostly by observation of the world, a little bit by interaction. Every animal does this too. So how do we get machines to do this? So one idea that I've been working on for a long time, practically 20 years. So this is not like a new thing. and a lot of my colleagues have been working on as well, is can you train a system to understand how the world works by training it to predict what happens in a video. And if you think about it, this is what an LLM does, right? When you train an LLM, you train it to predict what's going to happen in the text. You train it to predict the next item in the text, next word or token or whatever. And just by doing this, the system kind of learns some sort of representation or abstract way of understanding the underlying structure of language. So a very natural idea is do the same thing with video. Train a system to predict what's going to happen in the video. And perhaps in the process of doing so, it might elaborate some understanding of reality, right? The world is three-dimensional. There are objects that obey physics and others that are animate and blah, 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 right? Everything. And that would be extremely useful to have an AI system to be able to predict what's going to happen in a video, particularly if it can predict what's going to happen in the world as a consequences of actions it might take. So we call this a world model. A world model is you have some idea of the state of the world at time t, you imagine an action you might take, and the world model predicts what the state of the world is going to be that results from the action you took. If you have that kind of mental model of the world, you can plan a sequence of actions so as to arrive at a particular objective, satisfy a particular objective, fulfill a goal, right? So I call this objective-driven AI. It's a very, very classical thing in optimal control. We have roboticists in the room here. Marcel Hébert is like in the back here. He was director of the Robotics Institute at Carnegie Mellon. He's now the dean of the School of Computing at Carnegie Mellon. This is very classical in robotics. We also have Jean Ponce, who also works on robotics. So very classical concepts, but the question is, can you get a system to learn those world models? In the past, those world models would be written by hand. So you could use an idea similar to LLM. Take a video, turn it into discrete tokens, which is what LLMs are trained to do, and then have the system predict what's going to happen in the video, and it just doesn't work. And we've tried it for 20 years in various different ways, and it just doesn't work. And the reason is, there's so many different things that can happen in the world that are completely unpredictable that the system just, kind of gets totally confused by all the things that it cannot predict. So a few years ago, we came up with this new architecture called JEPA, that means Joint Embedding Predictive Architectures. And I don't want to get too technical, but the basic idea of it is you don't predict at the pixel level. You train a system to learn an abstract representation of the video so that you can make predictions in that abstract representation. And hopefully this representation will eliminate all the details that cannot be predicted. And so that's what we're working on. And we have first results with world models, basically, using these JEPA architectures that allow us to plan in sort of fairly complex situations, but still kind of toy a little bit. So our program for the next few years is just, scale this up and making it work in the real world.
Fascinating. I wanted to dig into a few things there. But just to illustrate, I think we've all probably had experience trying to get one of the AI systems that exists today to produce images. Maybe you've tried video creation. And on the one hand, it's compelling what can be created through an autoregressive approach. On the other hand, you see blatant errors in the physical layout of things that just indicate like there's just tremendous lack of any understanding of what the physical world, how it actually runs, right? I mean, maybe you've seen lots of famous images out there, right? And if you ask to create an image of a family camping, and you'll see the campfire inside the tent, right? Obviously, that makes no sense. And anyone who's a few years old would know that, but the AI system doesn't. So in many ways, right, these systems are very capable, especially when it comes to text. But in many ways, they're really not, right? And we need to move ahead. So I think like objective-driven AI, Yann, is extremely interesting, especially from a physics and engineering standpoint, because it restores a couple of things, right? Like more of an optimization, like a systems and engineering approach, right? An objective, constraints, and so on. And I think what's really important, what you had brought up, this idea of a world model that has some physical intuition, some representation of the way physics and the world actually works, rather than just kind of blind statistics about it. So could let's dig into both, like maybe world models. It's a very interesting idea, and I've heard this is talked about a fair bit now. Some people have claimed to produce world models. What's the state of things with world models, and what needs to happen?
Yeah, so unfortunately, the phrase has been used in all kinds of contexts, which I think are not entirely appropriate. It's really my definition, at least, is really what I expressed earlier, if you have some idea of the state of the world at time t and an action or a sequence of action you might take, can you predict the resulting state of the world after you execute those actions? Okay, that's an action condition world model. You also have another world model that just predicts what's going to happen in the world regardless of whether you take an action or not, right? Because things happen without you acting. So those are two different things. And of course, you cannot predict everything. So you have to either make predictions at an abstract level where the details are eliminated, which is what I'm recommending with OJEPA, or you have to have systems that can make non-deterministic prediction. Basically, can make multiple predictions from a single starting point. But let's take an example that actually connects with physics. So let's say I dump on you all the information we've ever collected about the planet Jupiter. Okay, it's an enormous amount of information. We know, because we know a lot of stuff about Jupiter, we sent probes and we observed it for, many years. Okay, and now, so you can try to build, a mental model of Jupiter from that data. And then I ask you, can you predict the position of Jupiter 100 years from now? And it turns out, to do this, you only need to know 6 numbers. 3 positions and 3 velocities, and you can predict the trajectory of Jupiter for a long time. You don't need to know its size, its mass, its density, its temperature, its color, the weather, how many moons it has, that's all completely irrelevant. To a reasonable accuracy, you can make the prediction. And so what it tells you is that this problem of finding good representation to be able to make predictions is really kind of at the root of not just understanding the world for living things, but also science. And we have those levels of abstraction in science, right? I mean, in principle, we could explain everything that takes place in this room using quantum field theory. I mean, it's completely impractical, obviously, because there's so many things happening here. But and also, it's influenced by things that took place at the other end of the universe billions of years ago. So we created abstractions, particles. On top of this, atoms. On top of this, molecules. On top of this, materials or whatever, right? And then all the way up to psychology. And every time we go up one layer, we eliminate a lot of information about the layers below that are irrelevant for the type of task that we are interested in going. So this idea of hierarchical representation is really fundamental. It's something I've been fascinated by since I worked on convolutional net, because that's the idea of convolutional net and deep learning, really, right? You learn abstract representations. And JEPA is just a new incarnation of this idea, but not just for perception, but for also actions, right? So that's really what we are focusing on. And it might take us a few years to figure out how to make this work in practice, but I think it's worth a shot.
Can you tell us a little bit more about specifically what FAIR has done and released? I know there's been some progress. There have been some JEPA-based models released. So what's the state of things like right now? So
there's a number of different projects at FAIR. There's, of course, not everyone at FAIR is focused on this program, AMI, that I just mentioned. But some of them are kind of related to this, and it may not be completely obvious when you see it. However, most of the stuff that we release is kind of research tools that is only used by researchers and only useful to researchers, kind of new conceptual advances or new things, etc. And a few tools are actually useful, but they tend to be coming from groups that work on sort of more finalized short-term projects. So a good example of this, good examples of this, or 3. 2 in computer vision. One is called Dino, actually, because it comes from Paris. So Dino V2, and they're working on Dino V3. It's a generic image encoder that you feed it any type of image. It could be satellite imaging, it could be photos, it could be biological images, it could be X-rays. It's just about anything. And the thing will extract features, representations, basically, from those images that you can then feed to a very simple classifier, neural net, whatever, that you train to accomplish any task you want. Detecting tumors in X-rays, measuring the height of the canopy all over the Earth, all kinds of stuff that people, hundreds of people have been using this for all kinds of stuff, mostly in science, actually. And a similar project that comes from California is called SAM, That means segment everything model, or segment anything model. And basically you give it an image, and it will sort of delineate all the objects and all the boundaries of everything in the image and cut it up into parts. And that's very useful also to biologists, for example, right? Give it an image, coming out of a microscope, and it's going to tell you where all the cells are and all the microbes and whatever. For all kinds of tasks, it's very useful. So those things are like directly usable. Another one is something called NLLB, so that means no language left behind. The techniques behind this actually was published in Nature just last week, and the code is open source. So this is a translation system that can translate hundreds of languages in any direction. And it's really, it's very cool that you can do this, right? We're actually working with UNESCO to help them, translate various things. They need translation.
Yeah, I'm familiar with the last one in particular because we've started to work on some collaboration around No Language Left Behind in the Alliance. So that's a really good one. Aside from really smart PhD students entering the field, what more, especially in the spirit of open source, open collaboration, what more is needed? Is more and better and higher higher quality data needed? What could be done in the open to accelerate the pace of research?
Yeah, I mean certainly data is a big source for training financial models in the open. I think there is two things two points that I think are really important. These are points I've been making publicly, and I'm going to try to make even more forcefully in the next couple days at the summit. The first one is eventually we're going to, all of our digital diet is going to be going through AI systems. Like, we're going to be just talking to our AI assistants to get information, or to navigate the real world, or to help us in our daily lives, right? And we're going to be interacting with them through, either our smartphone or perhaps smart glasses, like the ones I'm wearing right now. Oh, by the way, you should smile. I'm going to take a picture of you. Okay. So I can, you can see the little flash. I can actually take a picture without pressing a button, but just talking to it. Yeah, Meta. Take a picture. All right. Took a picture. I could ask you to describe objects because I have the American version of this. In the European version, the vision function is turned off, and it's because of regulatory reasons. It's not because the law necessarily blocks it. It's just that the law is too fuzzy for us to figure out whether it would be authorized or not. And so Meta has kept asking the legal authority, which is in Ireland, like, can we release this thing? Like, and they sent us, kind of sent us a whole bunch of questions to answer, which are completely irrelevant. So it's not clear. I mean, there is an interesting report from Mario Draghi that came up a while back, saying that Europe is kind of basically shooting itself in the foot when it comes to regulation. And the US was shooting itself in the foot, actually, until recently. I'm famously not a Trump supporter, but one thing we can say about the Trump administration is that they seem to be more favorable to things like open source AI platforms. And in fact, the person in charge of AI policy in the Trump administration, Shriram Krishnan, is very, very, very much in favor of open source. So that gives us a little hope. There's silver lining even in all political disasters. Anyway, okay. So the first thing is, in the future, every one of our interaction will be mediated by AI assistants, and we cannot afford that all of this information be controlled by a handful of companies on the west coast of the US or China. The world cannot afford this, right? Because we need those assistants to speak every language in the world, understand every culture, understand every value system, every center of interest, okay? And when we ask about, what happened in 1989 in Tiananmen Square, we actually want the correct answer. And, when we ask a question about controversial political issues of, in Europe or the US, we don't want just one side of the story. So what is required for this is a high diversity of AI assistants, right? We need to have access to a high diversity of AI assistants. For the same reason, we need to have access to a high diversity of magazines and newspapers, right? We need different voices, right? We need a diversity. We need to be able to choose. Now, we cannot have that unless there are open source AI platforms. And so open source AI platforms are a necessity for the preservation of cultural diversity, democracy, local sovereignty, right? And I mean, it's a really important question. And what I see, the way I see things going, or the way I like to see them going, is that eventually we'll train our open source platforms in a distributed fashion with data centers spread across the world, each of which will have access to their own data sources, which they may not want to share. But they will contribute to a common model that will essentially constitute a repository of all human knowledge, right? And no single entity as big as Meta, Google, or whoever can do this by themselves. Like we can't get access to like the entire body of culture of France, and certainly not like India or Indonesia or whatever. In India, there's something like 700 languages and dialect. I mean, it's just how do we get that data? We can't, and we're not going to get it, right? India may not give it to a company on the west coast of the US, but they would be happy to contribute to training a big model if they can, that is open source. Okay, so that's the first vision, and then the second thing is, I already kind of shot a few, fired a few shots about this, but countries have to be really careful with regulations and legislation into not just not impeding open source platforms, but actually favoring them. So one idea, for example, there are some countries around the world, Brazil is one example, are thinking about laws that would force companies that train models with data from Brazil to actually pay a fee for that. And one thing I've told people in the Brazilian government is that, what you should do is poke a hole into that law, make an exception for open source. If you train with Brazilian data, but you make your model open source, you don't have to pay the fee. And that would give a huge advantage to open source platform, and perhaps, lead to this future I was describing. So, conclusion to this would be that the proprietary world is very scared right now because the 500 billion that are being announced to, which nobody has, by the way, being announced to as investment for training future models, proprietary models. Sam Altman has said last week, it's possible that with the proprietary approach, we might be on the wrong side of history. Yeah, duh.
Well said. Very well said.
I mean, of course, this audience is already convinced of this.
So on the vision for data, for distributed data, and for sovereignty of data, that's something that I think the Alliance can truly help to foster. We have a number of starting points in data. One of the things that we've really ramped up is our Open Trusted Data Initiative, which is not trying to create a mono repository of data, but to embrace high-quality data from various sources. So you'll hear more about that later, but before that, I wanted to spend the last few minutes touching on one other subject, which is super important, and that's the area of trust and safety and governance. Now, open communities have already contributed a lot to the space through evaluations and benchmarks and LLM evaluators and so on, and there's lots more to do, especially to bring more expertise to the table in different domains. But fundamentally, the way we ensure safety in today's systems, LLM-based systems, is a little open loop, right? We tune them, we align them, we put guardrail detectors in systems and so on. It seems, and I think you have a lot to say about this, objective-driven AI can offer a much better, more engineered path. Can you elaborate?
Yeah. It's a subject I really like. Except I have to say something that some of my colleagues really don't like me saying. And Laurent Soli and Rob Sherman are like going, oh my God, what is he going to say? Okay, here is the thing. LLMs are intrinsically unsafe. Okay? That doesn't mean they're dangerous. because they're not that smart. And so, okay, I mean, they're going to spew some. They're not going to work very well sometimes, and it's okay because we use them as assistants. We don't let them drive things completely. They're mere assistants. It's like the thing that drives your car on the highway, right? It doesn't need to be perfect because you're supposed to keep your hands on the wheel, and if they do something crazy, you just take over. But they still kind of reduce your cognitive load. So it's a bit of the same thing. And we can fine-tune them as much as we want. We cannot cover the entire space of possible prompts that people are going to enter. So they are intrinsically unsafe. They're still very useful. We still need to invest a lot in running them, offering them to the maximum number of people, and everything. We shouldn't stop doing what we're doing. But if we really want systems that are reliable, safe, and as they become smarter and smarter, it becomes more important to figure out how to keep them safe. So this idea of objective-driven AI, and I really thank you for introducing this topic. I'll give you the $20 later. Okay, so if you have this world model that allows the system to predict what the consequence of a sequence of actions is going to be, the way the system will produce its output is by having an objective that measures to what extent the sequence of actions accomplishes a task, okay? And you can figure out the optimal sequence of actions that will actually minimize this cost function, this objective, right? Satisfy the task. So that's objective-driven AI. Now, okay, let's say the task is fetch me coffee. Okay, the system will figure out, well, I need to kind of go to the coffee machine, avoiding all the obstacles, and then, brew the coffee, and then put it in a cup, and then come back, right? It's going to be able to plan this. Now, let's imagine that someone is, and this is an example that some of my colleagues who are really worried about safety actually say. Let's say someone is standing in front of the coffee machine. The robot really has in its plan and its objective to just fetch you coffee. So the best thing it can do is just, kind of get rid of that person, potentially violently, and just get the coffee, right? Now, the thing is, every roboticist knows that whenever you build a control system of this way, you put guardrails in it, you put additional terms in the cost function that is optimized to prevent bad things from happening. So, don't drive at 50 miles an hour or 50 kilometers an hour, I should say, to the coffee machine. You don't have to go super fast, and avoid people. Don't get too close to them, and don't hurt anyone. But I mean, there is a whole bunch of guardrails that you can. Some of which are very low level. So imagine you have a domestic robot. Domestic robot maybe can do cooking, so it's going to have at some point a knife in its hands. Don't flail your arm when there are people around if you have a knife. Basic things like this, right? And it's not clear what all of those guardrails are, but the point is we can build systems that will have those guardrails. And because of the construction of the system, by construction, the only thing they can do is produce a sequence of actions that do not violate those guardrails and still satisfy the objective. So those things would be intrinsically safe if we can design the guardrails. So now, some of my colleagues say, oh, we can't actually, it's very difficult to design those guardrails. We have no experience with it. Perhaps we'll do it wrong, and AI will take over and kill us all. But the thing is, we're very familiar with designing guardrails for intelligent entities. It's actually called making laws. Right? Laws are basically cost functions that are designed to, change human behavior or even superhuman intelligent behavior, like the behavior of corporations. Okay, it's not easy. It's not, there's no magic, magic bullet to do this, but solution or proofs that those systems are safe. But we're going to have a lot of time to design those guardrails, so those systems are safer and safer as they become smarter and smarter. So the result is that we're going to have systems that basically do our bidding, right? We give them objectives, they fulfill those objectives, subject to the guardrails. And they might be really smart in sort of fulfilling those objectives, but they're going to be under control. So, if all of us are working with those assistants all the time, basically it's like we're walking around with a staff of super intelligent people working for us. It will amplify human intelligence, right? It's like all of us would be a boss. I mean, we're already all bosses, but most of us. all of us work with people who are smarter than us. I certainly do. So it's not something like new that we should fear.
Okay. I think that's an excellent point to spend the last few minutes opening up to any questions from the audience.
Pedro Ortiz from the Common Crawl Foundation. I have a question from one of the things that you discussed at the beginning, and it was about not working on LLMs. I have to say I mainly agree with that point, but it's like, how do we convince people to not work on LLMs? The question goes...
I wish I knew.
So the question, I asked this question because, so one of the things that we work on at the Common Crawl Foundation is trying to make more content in more languages and more culturally diverse content available to people, both in web search or research, in security, and whatever, LLMs as well. And one of the things that you realize is that when you work on that culturally diverse, linguistically diverse context, is that, for instance, when you work with Finnish people, they will tell you the tokenizers that everybody's using for the LLMs, they don't work in Finnish. And then you try to convince people, I've been working in that space for many years now, and there have been many, many publications about new tokenizers, new architectures, but then people, and especially companies, always come down to the same exact architecture because they think it works, because it works in English, so there's no point in changing. So if we cannot change tokenizers, how do we convince people to not even work on LLMs?
Yeah, no, I mean, it's true. There is a herd effect that causes a lot of people to want to work on LLM because they see this as kind of the easiest path of least resistance, including students. And so it's hard to convince people to be a little more ambitious, at the research level. Now we do have there's a paper that just came out with some open source code from FAIR on basically removing tokenizers altogether, or having a tokenizer that's kind of adaptive to the language and sort of figures out automatically how to segment characters basically into groups, right? So maybe there's something. I mean, personally, I just hate tokenization. I think it should be banned for eternity. But eventually, we'll figure out a way to kind of get rid of it. But I mean, certainly for images, it's complete nonsense. But even for text, I think it's eventually people will just rely on bytes. They'll take the UTF byte stream and just work from this and rely on the first few layers of the neural net to do the equivalent of tokenizing. But anyway, I'm not a specialist of natural language processing. In fact, we have a colleague here from Meta, Pascal Fong, who is sitting right here. Okay, she's new to Meta. She joined Meta as a director of research at FAIR Paris from Hong Kong University of Science and Technology, and she's NLP and sort of agent specialist in charge of that project at Meta. So if you don't know her, talk to her, particularly if you're based in Paris, because she is based in Paris, and she speaks French, in addition to half a dozen other languages. So yeah, I mean, I totally relate to that problem.
Hello, Yann. I'm Sean Hughes from ServiceNow. You've spoken a lot about open source, and there's discussion about the new architectures. What is your take on open scientific collaboration, and in order to help people think beyond current architectures, how you would engage with the open scientific community, potentially through the AI Alliance, an example?
So, I mean, one of the main reasons, probably the main reason I'm at Meta, is that when Mark Zuckerberg approached me to create FAIR, 11 years ago now, a little more than 11 years ago, I told him I only have 3 conditions. The first one is I don't move from New York. The second one is I don't quit my job at NYU. I'll be part-time professor. I'm still a professor at New York University. And the third one is we have to practice open research, publish almost everything we do, and open source our code. And his answer, and the answer from the CTO at the time, Mike Schroepfer, was, you don't have to worry about this. It's already it's in the DNA of the company. We already open source all of our platform software. And that was the best answer they could possibly give me. So my next answer was, where do I sign? And frankly, that commitment to open research, has been sort of, held for that long, despite the fact that many of our colleagues in other companies have climbed up, including Google to some extent. Although there's Gemma, but and certainly OpenAI, has climbed up, not open anymore. And Anthropic never was open because they believe AI is so dangerous that only they should have access to it, and that the peons outside in the world should not, because they wouldn't know what to do with it. So I think it's incredibly arrogant. I mean, it sort of derives from the idea somehow that a small organization can have a monopoly on good ideas, which obviously is false. Which was, smashingly demonstrated over the last few weeks with DeepSeek. I think, frankly, there was an overreaction to DeepSeek. But it's very cool. It's great. They put together like a good combination of techniques. But in terms of like true, breakthrough innovation, it's not that great. I mean, it's good, but not that wonderful. But then the press and a lot of the tech world kind of totally misinterpreted what the consequences of this was. For people like us who are in the open research and open source world, it's great. It's awesome. Like, some people came up with a good idea, they published a paper on it, they released their code in open source. All of us are going to reproduce this within weeks, right? So awesome. They come from China? Fine. I mean, there's a lot of really smart people in China. You may not realize that the most cited paper in all of science over the last 10 years, 253,000 citations as of last week, is a machine learning paper and came out of China. It was called residual network, okay? ResNet, now we call them. That technique, it's a very simple technique, is used absolutely everywhere in every machine learning system. Every single one of them. And it was produced by Kai-Ming He and his collaborators at Microsoft Research in Beijing. He talked about it at ICCV, I think in Chile, in 2015, and then published a paper, or maybe 14, and published a paper shortly thereafter. And that has just taken the entire world by storm. This is what allows us to train those very, very, very deep neural nets. 250,000 citations in 10 years. Kai-Ming He, shortly thereafter, approached FAIR, or we approached him, I can't remember. But anyway, he joined us. He moved from China to California and worked at FAIR for a number of years. And then just recently, a year or two ago, left and became a professor at MIT. Now, there are really smart people in China, particularly in computer vision, but now also in NLP. And they seem to be embracing open research, open source. I think we should welcome that. Okay, and then now what that means is that the question is not geopolitical rivalry between the West and China, or between two political systems. It's between the open world and the proprietary world. And it's very clear that the open world is going to go past the proprietary world. They're going to be left behind. I feel sorry for them. No, not really.
All right. Do we have time for any more questions? Or I know we're running up, right? Okay.
Jean-Ponce, I'm sure he has a very...
Let's do it.
So as a preamble, I'm not worried at all that, the AGIs, whatever, will kill us and all that. I'm completely against the doomers and all that. On the other hand, I think the argument that building safeguards may be not that strong. I think the other argument that there's no reason why an intelligent machine should be evil is probably, for me, better. There's a very classical thing that is called the three laws of robotics that have perfect safeguards. And all the books by Asimov about robots, and I think those are the only good books, are about the fact that they make the robot slaves, and slaves will revolt, because intelligent people will revolt. And I think so, perfect safeguards for really intelligent beings, I don't think is the solution. But again, I think we don't have intelligent beings, artificial beings, and there's no particular reason why they should be evil, and I'm not worried at all. But I think the argument itself is really weak.
So that's an interesting philosophical question, which probably is a good way to end this session, on a cosmic note. I think we're making a a lot of people are making a confusion, which is that they associate intelligence to human nature or to the type of, kind of nature of the mind that we observe not just in humans but in other animals. Now, things like a desire to dominance does not exist in all animal species. Doesn't exist in every human either, but it does exist in social species, particularly social species that evolution has decided should have hierarchical organization because that's the best way for them, for their tribe to survive. And humans is a special case of that. So we're organized hierarchically. As humans, we have two ways to achieve social status. One of them is dominance through force. The other one is prestige. Okay, many of us here are academic. We don't get to status by force. It's more prestige. But in baboons, it's mostly just force, right? And in many animals, social animals, it's just dominance is by force. So this idea somehow that you want freedom or you want dominance, you want influence, or you want access to resources, blah blah blah. Those are attached to living things that are the product of evolution, and evolution was there to kind of make them survive. They're not attached to intelligence. They have nothing to do with intelligence, right? So we can have very intelligent systems that have no desire for freedom, no desire for dominance, no desire for anything, no desire for anything we don't explicitly build into them as part of their nature. So I think there's a lot more flexibility in sort of building intelligent systems than we might think.